You guys have no idea what this event's about? That's intentional. I call it organized chaos, right? It's chaos, but there's some planning, but the rest of it we're going to figure out on our own. So let me get the big things out of the way. Is this the MIDIC competition? Is it where we get to submit to NASA? Is it the $20,000 competition? Kind of. What we're doing is we're having a local round that's HCC only, and we're getting to put our projects together to do our practice. We have a local prize money. Tomorrow, you'll be asked to join us at the West Loop Auditorium, at the HCC West Loop campus, and I will be telling you later today a link where I need you to upload all of your project details, whether it's the presentation, the white paper, the video. I'll have all of that. I'm going to ask you to upload that by 11 a.m. tomorrow. That's going to be the cutoff time, 11 a.m. So that means you have today and tonight, and then early morning tomorrow to do whatever you need to do, but you got to submit your projects. Once you submit your projects at 11, I'm going to have a bunch of random strangers look at them, call them our SCORE faculty mentors. These are retired professionals in the Houston region that are there to help with business model or business advice or business mentoring. They will help me pick the top 7. If the scores are very close, I'm going to allow top 9. Okay? If the ideas that are coming in, I'm going to allow top up to 9. If the scores are very spread out, then I'm going to take the top 7. Okay? Top 7 will be invited to present from 1 p.m. to 3 p.m. on the center stage and the auditorium. What that means is everyone's invited to be there, but only the top 7 will get the opportunity, because why will these top 7 get selected? 1, they completed everything before 11 a.m. They gave us things to grade before 11 a.m. and they were graded really well. Some random person thought that this project's pretty persuasive, that this project is worth exploring. Someone who doesn't know you, completely independent jury, right? That's important. That's what you were told. No, it's not like I know you, so I'm going to favor you. No. Random people are going to look at your project and rate them just to help us screen it. Once you're there in the top 7 on the stage, now we have some judges. We've invited HCC faculty, we've invited folks from SCORE, folks from TIE, which is another organization in town, who will be now sitting as judges. We're going to use the rule of large numbers and try to have like 10 judges that are giving feedback to your actual live presentation. The live presentation has to be less than 3 minutes, but we're going to say up to 5 minutes for Q&A. So we're going to try to rush you a little bit on the stage. The idea is like an elevator pitch. You just met someone, and now you're trying to convince them to follow up with you. But it's not the call where you give them all the details. But that's the call that you tell them, this is a great idea. There's a problem in the world that you're solving with hard science. And hard science backed by NASA IP. That's what you want to convince somebody tomorrow, right? If you're the top 7, those judges, all the scores will get tallied, all the data, all the feedback from written feedback will get collected and will be made available to all of them, all of you. The ones who score high will be selected as first place, second place, and third place. There's a cash prize of $750 for the first place, $500 for second, and $250 for third. But that's not all. We're going to ask that team within 24 hours to submit directly to the NASA's website for the MIDIC project, which closes, if you saw the timeline, it's at October 16 on Monday. So if your team wins our local round, we expect you to be ready to submit what you've already prepared straight onto the NASA website. You will need a faculty IP. You will need to show that you took part in this event. So I will be making available for you a certificate of participation in our hackathon at Houston Community College. So all of you will get something with your name on it. As long as you check this, I'll have those printed, or I'll make them available digitally for you to print with our school logo and signature and all that, right? So you have that to submit as part of your NASA project. They want to see that you didn't just show up and took it. NASA requires that you take part in some sort of a school-sponsored hackathon. This is the school-sponsored hackathon. So far, so good? Yes? Simple? Guess what? The NASA competition is the $20,000 competition for phase 1. So once you have submitted there, then NASA will take its time in doing its own judging and its own scoring. I'll invite you or your team for their round. The probability is one. If we submit 7 projects from HCC, and by the way, I'm going to encourage whether you win top 3 or not in local. If you were top 7, I want all top 7 to submit the project to NASA. It just works better probability. If we submit 7 as HCC, the chance of one of us getting the national prize, it's higher. So that's my intent. My goal really is that you've got great projects, you've got great mentors in your classrooms, you've been working on this, some of you for a little bit, that you've been thinking about this since the flyer was made available. So I really would like for all of you to submit. You will need the stuff tomorrow. That's a letter of participation. You will need a faculty. If you don't already have a faculty mentor, find one today. We've got deans in the room. We've got directors in the room that can help you. If you still need a faculty from engineering or faculty from natural sciences, just ask. And what they'll do is they'll get a letter of support for your project, signed by that faculty. You do need that. Now they say it's optional, but I don't want any option. I want us to submit everything that's on that form and submit it with like precision and formal accuracy. So there's no reason we get dinged on our score at the college. So far so good. Okay. It is time. One more. Yes, Jeff.
You want to mention the spring?
No. We'll wait because right now our focus is fall. I guess I'll just say this in honor of Jeff. If you don't make it tomorrow for whatever reason, but you love your project and you need more time, you can submit it in spring, in the spring deadline. So the MIDIC project is fall and spring. But I don't want you to use that as an excuse. This is not an excuse to procrastinate any further. Tomorrow is it. Tomorrow you got it, for this season. Tomorrow is the deadline. So don't grab, all right, we'll just do it later. There's a reason hackathons work, because they're timed. It's forcing you to do something quickly. And that momentum you don't want to lose. Yes, sir.
Isn't it possible that if they submit in the fall, they can refine it?
There is a possibility of that. Yes. Yes.
That's the advantage of submitting in the fall.
That's good. That's good. Put your best foot forward, but if not possible this time, you do have a second round. You can go for it. But it's 10 o'clock, and let me invite Mr. Grant to come inspire us for day 1 of our Inventathon. So for those of you who do not know, Mr. Grant was the Sector Vice President and General Manager of Space Systems for Northrop Grumman, which is the prime contractor for NASA that worked on the James Webb Telescope. If you know about the James Webb Telescope, the beautiful marble engineered telescope that is 1 million miles away from Earth, stationary, it's not rotating anything, it's stationary in Earth, taking amazing pictures of our universe, and it's looking back in time, telling us the history of our universe. So what a great accomplishment for you and the 10,000 or so people that represented it. But you'll see that busy people, they don't just have one title. They do many more things. So Mr. Grant is also the chairman for the Space Foundation on the board. He's also part of board of directors for the Aerospace Corporation and the board of director for Answer Corporation. He's received multiple awards from the CIA for the Distinguished Intelligence Medal. He's also received the Intelligence Medal of Merit, and he's also a published author. So you could look him up as author on Amazon and find his books about CIA and his fictional book about the CIA, and check that out. But at the same time, I don't want to take away any more time, but we really, really appreciate you, because we said, can you do Zoom? And you said, Ravi, I'm just going to show up. That is amazing. Thank you for being here. Thank you so much. Yes, yes.
Let's see. Let me start by saying I'm so thrilled to be here. Ravi's exactly right. I had the opportunity to sit in front of my computer and project my face from Los Angeles. I hate Zoom, and I find it to be ineffective. And part of the thrill I have after having a career and the opportunity to meet with youngsters like yourself in college, the joy I get is actually meeting folks and talking to you and hearing directly from you. I think that inspired me to come here and talk to you today. Before I go into the presentation, I wanted to just reflect a bit on innovation and an event I had some years ago. I had the opportunity to talk to Jeff Bezos, and the founder of Amazon. You think about folks like Jeff Bezos, Steve Jobs, and others. They changed the world with their innovations. And he was describing how he had this idea of putting an online bookstore together, where the problem he envisioned was you shouldn't have to pick a book in a bookstore that somebody selected that you should read, of whatever, 1,000 books. He thought you should be able to pick the book yourself and make it available. So he was pointing out a problem that most of us didn't think we had between a library, between a bookstore. We didn't know we needed the ability to select books. And he said that humans are amazingly resilient animals, that we accommodate problems. And he gave us an example, early cars. When it rained, they pulled over and stopped to wait for the rain to slow down. They didn't realize the problem they had was they needed windshield wipers until somebody invented them. And so he focused, he said, on innovation, on solving problems that people didn't know they had, versus just fixating on problems you think they have. So with that as a background, I wanted to spend a few minutes to talk about the James Webb Space Telescope. Why? Because it's a marvel of engineering, marvel of innovation, and a lot of the work took place right here in Houston. I note here on this graphic, it took 25 years of a very large team. I'm going to talk about the elements of that team in a few minutes. But if you can imagine a time when people were using both ground-based telescopes and then the Hubble telescope came into existence. Everybody here heard of Hubble? Amazing, amazing telescope. Let me just say a few words about Hubble. It weighs about 25,000 pounds. So think of it as a big satellite. It has an optic that's about 2.3 meters in diameter. So it's about 4 square meters of optics. It has no propulsion system, and it operates at about room temperature. And it's serviceable. There are many servicing missions to Hubble to both correct the optics early and then to make it better and last a lot longer. But at the time, you have to go back 30 years, the problem that the astronomers, cosmologists wanted to solve was to look back in time, further than Hubble could. If you think the Big Bang Theory is accurate, and there are people who debate that, they believe the universe formed about 13.5 billion years ago. And it's been expanding and accelerating ever since then. And that means that the origins of the universe come from a long, long time ago. And they've redshifted because of Doppler. And the combination of the distance and the redshift means that if you want to see back to the origins of the universe, the earliest galaxies, the earliest stars, you have to look in the infrared regime, and you have to have a really big optic, because you're looking at very dim objects. So in the 90s, people envisioned an optic that would fit in the shuttle bay, which was about 5 meters, which means you could have an optic of about 4 meters that might fit. The problem is a 4-meter optic wouldn't look back as far as they wanted. You needed bigger. And so at the time, people didn't think that was possible. The administrator of NASA at the time, Dan Golden, challenged industry, challenged government agencies to go figure out how to build a deployable optic, a segmented optic, large enough that would be able to solve the problem that the astronomers described. It not only needed to be big, it needed to be cold. because you're looking in the infrared regime, so you're looking for thermal signatures from the earliest formation of the galaxies. And to be cold, you can either cool it with coolers or you could passively cool it. Just not ever let it see the sun or the moon or any kind of radiation other than zodiacal light. So at the time, people envisioned a very, very large deployed telescope that would be permanently shaded, as Robbie said, not operated close to the Earth, but in fact at the second Lagrange point. There are a bunch of Lagrange points there. He said it's not moving, it is. It's orbiting the sun once a year, but it's in a different orbit than the Earth. It's a very unique orbit, gravitationally stable between the Earth, the sun, and the moon. And so that's where ideally you could put a telescope like this. So about in the late 1990s, they did start NASA, Goddard, Space Center at Goddard, started doing concept studies. And in 2002, they awarded a contract to what was then a company called TRW to build the James Webb Space Telescope. So let's take a look at that. Oops. This is an artist's conception of the telescope. I'm going to show you some pictures later, which put it with humans, so you can get a sense of the size. This optical, the diameter here is about 22 feet. The size of the sun shield is the size of a tennis court. And so what you're seeing here is the primary mirror, the 18 hexagonal segments that all deploy and orient themselves so there's no fuzz, blur in the picture. A secondary mirror that deploys out. And then on the bottom part of the spacecraft, I'll call it the tower system, the communication system, the point of control systems, and the like. And so this satellite was envisioned back in the late 1990s, put under contract in the middle part of 2002, and we spent 20 years building. And when I say we, I'm going to show you an example of what does it take, the innovation across not just the scientists and engineering community, but in fact, everybody who touched this project. Oops, it's going twice. Now here's a picture in Houston. In order to make sure that the optics worked, we had to take a fully integrated optical segment, and here you can see the 18 mirrors that all individually are controlled. They're made of beryllium. Beryllium has a very bad attribute. When you machine beryllium, it produces beryllium dust, which is toxic to humans. So the machining problem of this engineering feat was very difficult. And then we coated them with gold. So if you ever hear something's gold-plated, this is the James Webb Space Telescope. But here you get a sense of the size. You can see people inside the chamber here getting ready to put this in to do precision optical testing. This is way before the satellite was integrated. Here. Innovation. This chamber was built for the Apollo program, had to be modified for the James Webb Space Telescope. And of course, when you know it, we had a hurricane. While the telescope is in the telescope, in the chamber, it's very important to maintain the pressure, the temperature, and everything else during this. So the folks at the Johnson Space Center just went through heroics to make sure that the workforce, the scientists and engineers, all maintain the appropriate conditions of the telescope. And again, you can see here people and get a sense of the scope of this. I want to invite questions. I really don't want to talk for 30 minutes. So if you have a question, please raise your hand. I'll of course before time at the end, but I'd love to hear from you if this makes no sense to you and you want to elaborate.
Mr. Grant, I always wondered, why is this better than Hubble? I mean, that design is nothing like Hubble. Can you explain who or why does it look like a honeycomb? For bees.
If I were to have a picture of the Hubble diameter would be about this big. Right, so it's just like when you see sports photographers at sporting events, and you see their big cameras. It's their It's diffraction limited optics. The spatial resolution that you can get is dependent on the aperture diameter, the correlation between that and the wavelength of light you're looking at. So bigger apertures give you the opportunity to take better pictures. So Hubble was designed in the 80s, and that was as good as we could back then. So this represented a technology maturation. The segmented optics are like what you would see if you were to go to telescopes. There's one on the island, big island of Hawaii, called the Keck telescope, and it's a segmented optic too. These are hard to build. You can imagine getting all the alignments so that you have the wavefront error small enough to take good pictures. These are it's precision down to millions and billions of an inch of machine. Just give you hard engineering challenges. Yes.
You mentioned it's foils, so what do you mean by that?
It means that when you put it inside of a rocket, these three segments and these three segments fold back like you would have on a dining room table, right? And then the secondary mirror assembly folds back. So it all has to fit within a 5-meter shroud. So part of the challenges and the innovations that we were confronted with when you put all of these foils, it means that there's many ways for it to break. And so after we launched it and before it was fully initialized, there were some people that didn't breathe for 3 months. It's hard to believe humans can survive without oxygen for that long. But it was like this is like the ultimate transform. If I recall, there were like 1,600 single point errors. So if any one of 1,600 things went wrong, all the fancy folds would not come out correctly, and it would be a crippling mission. And of course, you don't want that to happen because we and other nations in the world spent about $10 billion building this to give you a sense of the scope of the program. So that was one of the phases of testing. Here we are in a high bay facility after the telescope has been fully tested here at the Johnson Space Center. It's been integrated with the sun shield. Again, you get a sense of the size with the people who are working on it. I'll say a few words about the sun shield. It's a 5-layer sun shield, and the idea is to keep this part and the instrument assembly that's right behind it, ISIM, very cold. And so it's designed so it's permanently shaded. It never sees the sun. It's as it orbits the sun, it's always looking out, but it can look up, it can look down from its orbit, giving it access to almost the entire universe. But it takes a year for it to make that orbit so it can look out, just as the Earth does. Yes.
Okay. I was curious because I always, when it took 20 years to make this machine, and over the years it went many ways because of manufacturing process and others, what type of technical difficulty most common?
Yes. Let me repeat the question. The question is, it took 20 years. What were the biggest problems? Actually, it seems like you read my notes. This is miracles. These were not problems. We needed to solve miracles. The first one was the mirror segments. It took the entire manufacturing capacity of the United States of America 5 years to build the brilliant oxide blanks, and we underestimated how long it would take to do that. So it's as good as we could do to build that much precision optical surface in an environment that was toxic to humans was a huge challenge, and just didn't go as fast as we had hoped. And the control mechanisms for those mirrors were they need to be very precise, down to, like I mentioned, millions and billions of an inch. Those actuators were quite a challenge too. There was another challenge in that one of the instruments, there are many instruments on the James Webb Space Telescope. One of them is called MIRI. It's a midwave IR instrument. Then it wants to be very cold. I mentioned the telescope operates at about 40 degrees Kelvin. So it's 40 degrees above absolute zero. The MIRI instrument operates at about 6 degrees Kelvin. So I'm sure one of your engineering teachers here told you that all molecular motion stops at 0 degree Kelvin. So we're within a few degrees of all molecular motion stopping. And what that means to the engineering challenges is every material challenge, every adhesive challenge, every bonding challenge is way, way harder than you can imagine to get refrigerators, very fancy refrigerators to work. We did this work. I'll tell you, we built an engineering piece of hardware for this that worked, and we never built another piece of hardware for another 12 years that worked as well as the first one. It was an accident that we built one that worked at all, and then we had to build another that would actually make it into space. Now the weight, yes, another engineering challenge. The weight. This weighs, it has 8 times the collection aperture, but weighs half as much as health. So the weight was a hard problem in this program. Because instead of just going to the lower orbit where Hubble operates, it had to go to the second launch. So you need a big rocket to do that. There's a trade that took place between the size of the rocket. We went on a French and Ariane 5, French Guiana. And so weight was another huge challenge. It takes very long pictures. When I say long pictures, some of the integration times, it points at a place in the universe and stares for up to 10,000 seconds. And so you think of a camera, a single lens reflex camera takes a picture in a 60th of a second. So here we are. And that's because we're capturing one photon at a time coming from over 13 billion years ago. It's a point of control. So you don't get a smear. Very, very powerful on this program. The last thing I note here is cross-organization interfaces. I'm going to say a little bit more about that. It was interesting when I came in, Robbie, at the first part of this maybe be networking. Because we all have a close circle of friends and we all go to our classes. In order to do this, now I'm throwing this up, Goddard Space Flight Center, Johnson Space Flight Center, Marshall Space Flight Center, Northrop Grumman, Fall, JPL, Jet Propulsion Laboratory, Lockheed Martin, University of Arizona, European Space Agency, the Canadian Space Agency. To solve a problem this big requires the innovation and cooperation between extraordinarily diverse organizations. And I will tell you,
How many people would that be? Because you're seeing 9,000 people under your team. What is the collective people?
it was part of like building pyramids. I don't know what the peak was at any point in time, but I suspect there were 100,000 people that worked on this.
Yes,
Can you tell me the specifics of what each company did? Like how they contributed?
The question is what the companies did. In a program like this, what you want to do is play to companies or institution strengths. So I showed you the picture of the Johnson Space Center. Why was it tested there? Because they had this huge thermal vacuum chamber built in the 60s, right? So we could have gone and built another one somewhere else, but the decision was made to come here. And decisions like that are made with companies also. I don't brag about Northrop Grumman here. We have built a lot of very large complex telescopes in our past. The University of Arizona, very, very strong academic institution in optical sciences. So one of the instruments came from that. Since this takes, you get it to orbit, it's supposed to last 10 years, it'll last way longer, I believe. And other countries want their scientists to have time on this, right? You can, any one of you can submit a proposal to the Space Telescope Science Institute for time on the James Webb Space Telescope. It's a remarkable democratic process. Go through peer review, but you could get time or your observations. But some countries, in order to guarantee time, like the European Space Agency and the Canadian Space Agency, contributed to the building of this. So you have some companies and organizations because that's what they do well. Others because they said we want time on the instrument, so we're going to participate.
Can students directly put in submissions?
Absolutely.
Like, they don't have to be part of that company.
Absolutely, no. Anybody in the world.
Let's do it.
There you
Get
go.
a project, I'll sponsor it. Let's go.
There you go. And the interesting thing is Hubble is the same thing with the Hubble Space Telescope. It belongs to the world. So
It belongs to the world.
yeah. The Sun Shield was another very hard challenge. It's designed. It's like SPF 1,000,000. So you have. It's always pointed at the sun. It's operated hundreds of degrees, and we're trying to get down to 40 degrees Kelvin. So it's designed to. It's like a great sun shield umbrella. So, yes.
How do you like manage a team of that many people or stay on track with the timeline?
Some of them have 5 team members and they're having trouble keeping everybody up.
That's part of the miracle of innovation. You have an idea, but you can't convince others to join you and parcel out the work so that you're playing to people's strengths. You're doomed, right? So that's what you're supposed to be learning here. There's no miracle. I have found threats work. Okay, praise works. This work depends on the individual. You know what motivates them to do their best. Threats rarely work. I did use this. Yes.
Earlier you mentioned about how the chamber or the West telescope was specifically built and there was difference to the ones with others satellites. But what was different about it? How is it?
The thing that was the question is what's different about this? So if I go backwards, the size. That it's almost impossible to test optics, what they call the far field. And so what we had to do was design a very specific set of test equipment on top of this that individually illuminated each of the petals and then the entire thing. And so it's the size of the optic that drove the very specialized test conditions.
That's a person there, right? That's
These
look
are
at the size. That's just one person. Look at that.
We weren't used to testing things of this magnitude at this quality. This chamber was used, like I said, the Apollo system, but they didn't have the needs for precision metrics down to femtometers. It's because of the combination. We had to do most of our testing when there were very few trucks driving around, just trucks miles away would shake them and cause distortions in the image testing.
That brings up another question about vibrations because you talked about the actuators and things like that.
Yes.
And I was curious to how all the millions of actuators that are close to show higher rates, and not make too much vibrations in the whole system to go off the dangerous business. Images because the mirrors would move to allow them to take pictures, so they would concentrate as well.
Yeah. What the question is about the vibrations, the actuators, and the idea here is we point at stars, we do optical alignments and set things, and they stay stable for a while. Then you have to go through another calibration process. So they're not moving during the image formation. The things that are moving, there are things called reaction wheels. Somebody gave me a spinner. Out here to see it being used. Yeah, worry spinners. That's how we control the spacecraft attitude. You spin a mass, and then you change the speed that it's being spun at, and it causes the entire observatory to change orientation. So it doesn't use gas to orient itself, but those spinning masses can't be out of balance. They have to be extraordinarily well balanced or they cause optical distortions.
So how we balance during image statements,
They're still spinning.
Okay.
It's just been very, again, it's a hard problem, but it's things have got to be balanced as well as humans can balance things.
Yeah, I've been on a third of these projects because, you know, it was engineering model to counteract all of the vibrations.
Yes.
Yeah. Running at the same time. It's very difficult because vibrations are kind of right.
Yeah.
Can't really get those. So to do it, counteract them, challenge.
Yeah, the gentleman was just saying vibrations can be random and counteracting them can be a challenge. It is. Yeah, we designed the telescope so that the frequencies that things are, we know they're vibrating at, it doesn't respond to. Right? So to try to minimize the coupling between the sources of vibration and the telescope. It's actually, the telescope extent, we look at that problem.
Ask what the shield is made of.
What
The shield, sun.
Oh, you're gonna like this.
it's mylar. And it was made by a company here in Texas that's coated with a reflective coating. It's sort of hard to describe it, but it's designed, each of the layers here is got an orientation so that the thermal energy that's coming through it, infrared wavelengths, bounces out. That's how we get the extraordinary attenuation. I may have it's on the bottom side of the shield that looks at the sun, it receives about 200 kilowatts, and then on the surface going this way, it's 23 megawatts. So it's going from kilos to millions.
That means that side of it's super hot, right? It's 100 degrees.
The bottom side is super hot. It's always staring at the sun.
And the other side you said was super cold.
That's right.
On one device. You get that? On one side the sun, this side is hot. On the other
Always look at the sun. Above here, never sees the sun. Another question.
To the guess that they generate power with the telescope.
Yeah.
But what have we learned from that to generate power by thermal variation?
We just use traditional solar cells for this. It's I think the power on this is about 4 kilowatts, 2 kilowatts. So it's not a big power user. Some satellites at geosynchronous orbit for communication are 15 kilowatts. So this has a reasonably modest power system and very, very little batteries because it's always in the sun. If there's a question,
it's back there yet.
I'll just
Yeah, it's so you mentioned exactly issues that can be like manufacturing, especially with the toxic material that is preventing together. What issues did you face trying to get that lens into space?
to get
That lens into space, if I can say it.
well, we got to
decide it's still heavy, right?
the question is what are the challenges getting these things into orbit? I would say, for the most part, the natural enemy of a satellite like this is man and Earth. Because we have to build these things in a 1G environment. And so you have to design everything knowing that it's going to sag, perhaps potentially take different shapes than it's going to be when it's in orbit and has what we call microgravity. No gravity. There is gravity, but it's spinning, so it's net zero. So the environment of gravity makes this very difficult to test. Air has water in it. We like our humidity. So we control the humidity of this during all the testing. And when we build it, we actually put distortions in, knowing when it gets to space, the moisture will evaporate and it'll go to the shape that we actually want versus the shape we tested to here on Earth. And so the complexities of testing it can be just very difficult in order to have confidence it's going to work like you want. The sun shield, I would just say it's almost impossible to test. It's so large, it's so non-deterministic on how it folds up and how it's going to unfold. It has so many creases and pleats. And so we just designed that and tested it many times on the Earth to gain confidence that it was going to work. There's a question in the back I'm going to take before.
So with that, so probably we'll see
Hold that thought. Hold that thought. The question was, can we see aliens? Right. So we're going to get to that. There is no. Yeah.
So I understand there's like tens of thousands of people psychology creating this machine. Can you tell us some of the programming languages that are used here?
Gosh.
What's that nothing?
Let's see. The question is, can I tell you about the programming languages? No, I started taking Fortran back in 1972, and I had to do key punch cards. Anybody here know Fortran? Yes, some of your professors. Faculty. Oh yeah. All right. So, and so being a program manager or a general manager of stations, they would never let me near the coding for this, but it was probably Java, Python. That's the root for the command and control. It's because you can imagine when we hire a workforce, we can't tell them the programming Fortran or COBOL. They look at us like we're crazy. Let me keep moving on. Right. So here's one of the fun things we did. You get on a program like this, and you have to, I'll be right with you. You have to convince people what you're doing, and it's sort of not crazy. And so this is a picture at the Goddard Space Flight Center, 2005. We built a full-scale model. I'm going to show you a picture of this week. It's been in Houston twice. And here you see team members from NASA Goddard employees standing under. And we shipped this all over the world. And we would have an ask the scientists because the scale of it was so large, nobody would believe you're doing it. If you put a scale model of a satellite hanging from the ceiling, you look at it and go, that's pretty boring. Scale model of the satellite. But when you go out and show people a full scale model and say, this is what we're going to be launching, we didn't realize it was 16 years later. But the idea is to show people how hard it's going to be and get people's enthusiastic support for it, which is critical. As we mentioned before, if you have an innovative idea, you need people to support it. You need them to understand what you're doing and why it's going to take as long as it's going to take and cost as much as it costs. Here we are in Houston. No, it's Austin, south by southwest. There's a question. How did you ship it all over the world? The question is, how do we ship it all over the world? We took it apart. We unbolted it. This is a scale model. Right? So we just put it in freight cars and stuff, put it on ships, trucks, and move around. But this was again, trying to go into U.S. citizenry. Well, at the end of the day, they spent almost $10 billion, and the idea is why, and what do they get? Now this, we launched it in December of 2021 on Christmas Day. You can imagine finalizing all the testing during COVID restrictions and the like. It was very hard. We shipped the satellite to Peru through the Panama Canal. So we had to put it on a ship down the French Guiana. And in July of this year, this was one of the first public released images. And when we saw this, I published it. People cry. And you can see things in here. You can see gravitational lensing. Anybody know what gravitational lensing is? Right. Tell us.
Oh, it's how gravity bends the light around certain galaxies and black.
Right, so his answer is it's how gravity bends light. It takes a lot of gravity to bend light. But what it allows you to do is it forms artificial lenses. So black holes create these lenses. And so each one of you can see these are galaxies that exist in the past. It's like, oh my gosh, it worked. So it's taken thousands and thousands of pictures, and they're mysteries. If you read about some of the scientific findings of these observations, there is a debate about the expansion rate of the universe, of the Hubble constant, and there's disagreement. And yes.
What's the big star, do you know?
I don't know. This guy right here?
Yeah.
I'm an engineer. Somebody does. Yeah. So the question was, what's that big star? We did use some guide stars for calibration purposes. I don't think this was one of them. Yeah, I forgot what it was. Gravitational lensing. So you can see evidence of things that support Einstein. Isn't that great? You know, some of the theories that Einstein put in place were confirmed by observations of Mercury back at the turn of the century, and then here we have more confirming data in 2021 that he was right. But then there's also indications that some of the stuff is not quite right. It's fun to see that. All right, so here we go. The question the gentleman asked.
I'm not sure the orbit is different than Earth, but it's still this 20 year. How do y'all like calculate the work? How does that work?
All right.
I don't understand.
The question is, how does that orbit thing work?
Yeah.
All right, there's a guy named Lagrange, and I think Lagrange was a French mathematician from sometime back in the 18th century, if I recall. And he actually predicted these things called Lagrange points. And you can imagine when you have big masses in our solar system or around the Earth-Moon system, there are places where the gravitational effects cancel each other out. Right? And so the net effect of that is to create a gravitationally stable point outside of Earth's orbital machine, which typically goes out to 20,000 miles through the signal segments. So the second Lagrange point is the one that we're at right now. And it takes some fuel to stay there, but not much, which is fortunate. So that's why we have a long-lived spacecraft. But it is kind of interesting to me that somebody 300 years ago, 350 years ago, thought about the place we're going to put this telescope in 2021.
You can look at the fidget spinners. The way when this is in motion, it's very similar. The concept is that computing, right? So when things are spinning, you could have, what is connected to very stable. That's why you're able to ride on a bicycle and not go crazy. It is not spinning. The motion keeps you balanced.
If you ever want to, if you have $10,000 you don't have any better use for it, you can take a thing called zero gravity. It's an airplane that flies parabolic loops. Oh, you're going to do that, huh?
Excellent. You know about it.
So you can go experience zero G during times of the flight path. So I have 500. Right. So the question about aliens. One of the interesting things about the James Webb Space Telescope is it carries instruments that can measure different pieces of the spectrum very precisely. So instead of just taking a picture, it takes a color picture, but it takes a picture with very small bandwidths across a large part of the spectrum. So here we're looking at Enceladus, one of the moons of Saturn, and there's something coming off of it. And here you're looking at wavelengths of light between 2.6, 2.7 microns. And you're looking at where it's sensing a signal. And of course, it corresponds to water. So we're able to remotely see that there's water on a moon of Saturn. Is there life there? I don't know. It's up to you guys. And somebody's going to have to go build a system to go explore a moon of Saturn. But we tend to think of Mars, the missions we've seen there, as being very important to find evidence of water, evidence of life. But here we're actually seeing water from the James Webb Space Telescope. Now here's where it gets really interesting. And there's a field of study called exoplanets. Anybody here familiar with exoplanets? Excellent. What's an exoplanet? Exoplanet is a planet orbiting not around our star, our sun, but some other star. And so if you go back in time, just 25 years ago, there was precious little evidence of exoplanets. There were people theorizing them, but very, very little evidence that any existed. As we speak today, there is evidence, measured evidence of over 3,000 planets. And I'll say that, and that evidence of over 3,000 planets gives the cosmologist belief that every star has a planet system. The reason why it's almost impossible to detect a planet around a distant star. It's very fortuitous, and so if you detected 3,000 of them, the inference is there are many more that we can't detect. And what we're seeing here is evidence of water. Again, we don't know what life would be like on a distant planet, but to our understanding of life, it needs water. And so here we're seeing evidence of an atmosphere. And if you can imagine how we see that, use my hands here. If there's a star and a planet orbiting, like the Earth orbits the Sun, and we're in line, every now and then it transits from being in front of the star, it's behind the star sometimes, but when it transits around the edge of the star, you get to look through the atmosphere for that moment. So that's what we're doing here. So we're looking through the atmosphere of this distant star. Roger, are you walking out of here? No. Okay. Okay, 5 minutes. So you'll see proposals going through Congress with NASA now for systems designed. James Webb Space Telescope wasn't designed to look for just evidence of life. But there will be telescopes in your generation that do that are focused on life. I'm going to finish up here. I'm going to get to cover most of this. So, I just want to point out Congress and we live in a democracy and doing hard things that take a long time. We overran this program. The company I work for, NASA, other institutions, by about $7 billion. When you do that, you get a lot of money. So if you want to know how to keep your innovation hat going, don't overrun $7 billion.
What was the percentage overrun?
4x. Yeah, it's horrible. I know. I'm being videoed out. But it wasn't because of malice. It was hard. We took on a challenge. The United States, Texas, NASA, the world, to do something that had never been done before. And I had contractors who work on my house at 50%. You know, you built another house before mine, didn't you? Yes.
So the Congress give you a budget, like
they did. So as a matter of fact, if you go to YouTube or somewhere,
yeah, to testify.
yeah, you'll see. Yeah, I'm there twice. The first time they yelled at me. The second time they were really really.
Did they base the budget based on what you told them?
Yes.
Initially, okay.
Yeah, and engineers can be wrong, right? It's not malice. It's just sometimes you don't truly understand how hard the problem's going to be.
Yes, I don't have money, so my family funded my private.
Exactly. He has that budget for his robotics project. And your parents are your Congress. Yeah, I like that a lot.
Was it worth it? Was it worth it? Like the whole experience of becoming advocates?
Sure.
Yeah, it's okay. I mean, like, you changed the, for the rest of the future generation. So money spent well.
I think the money was spent.
Yeah.
But, I have a very perverted view of this. But it's because the understanding that comes from this. I think that way. If you think back to caveman times and there was a rock But then near the fire, after you came away from the fire, you felt warmth. Somebody could say, what's that? It took somebody to build an infrared detector to actually understand what was taking place, right? And so detectors like the James Webb Space Telescope help us understand the fundamentals of science. And in order to advance the knowledge, you need a better instrument. And that's what this is. There will be a better one after this, but it should give all of you comfort to know, it takes a large group of people to do this. Yes, another question?
Okay, everybody, this is Professor Alice speaking now. I want everybody to read that first sentence, please. And never forget it.
Never forget.
Thanks.
Never forget. Building robotics, yeah. Yes. So just like this, human resources. Keeping people on a program for 20 years is hard. It is, you ask, how do we do that? Threats, bribes, whatever it takes. So you have to have a human resource organization to actually enable the team to continue the innovation that they started. Facilities engineers, they're just sort of unsung heroes of hard, complex problems to put the facilities together. The financial challenges, we talked a little bit about that. Dealing with our overseers in Congress, we had great support from some skeptics. Representative Ralph Hall used to be a congressman from Texas, who's one of our great supporters. Manufacturing, we talked about how hard some of this is, and it's never easy. So
so June Keller, right? The engineer in the room told you to look at safety. Let me tell the business perspective and the entrepreneurship perspective is going to be that bullet right there. Management of all of this, all these conflicting demands and priorities. Those things are tough, but it's doable. It's doable, but don't give up just because you can't get everybody to see the same picture at the same time.
yeah, what I'm really trying to emphasize here is a good idea is a good idea, but seeing it through takes a lot of help. And even if you're not the person that has the idea, or even if you're not the engineer or scientist, there's a role for you to follow through with these innovations that the teams that you're on is working. Yes.
Yes, I have. Opposed to just keeping everyone on board, how do you make sure everyone's using the same, everyone's getting their stuff? How do I explain this? In simplest terms, how do you make sure everyone's moving the right measurements, the same measurements, and on the same board when they're working on so many different moving parts?
The question is how do we make sure everybody's on board? It comes through rigorous documentation. And so the specifications that you have for a system of this complexity are very detailed, but the interfaces are also extremely detailed. So if you're building an instrument package that's going to bolt on to something else, exactly the weight, where the bolt patterns are, the material stiffness, every attribute is documented, and that's done by a systems engineering team. And I can't say enough nice things about systems engineers. They take extraordinarily complex problems and they turn them into executable bite-sized problems for lots of people to work on. But at the end of the day, it all has to work together. Okay? So I think I'm out of time, and I really do appreciate your questions, your engagement. It makes me I'm comforted by seeing the next generation here today and your enthusiasm, your innovation and invention. And I really wish you all the very, very best. And thank you for allowing me to join you today.
So I cannot let you go without showing your music video to the students. Because engineers can have fun. I'm going to go to the beginning. And it's going to volume. It's 5 minutes, folks, but
5 minutes, 52 seconds and counting. We're on time at the present time. Astronauts report it feels good. T-minus 25 seconds. Guidance is internal. 6, 5, 4, 3, 2, 1.
back into my future to see how the things that I am make the things I'm gonna be. For 20 long years, try to make it work. Now she's hanging up the stars while I'm grounded here on earth. I looked up at the stars above to finally see exactly what it was she never saw in me. I just had to know. She's looking back. She got stars in her eyes. She belongs to the world now. She's no longer mine, no longer mine. I wanted a future. She keeps looking at the past. She's got 18 golden mirrors. She's way too good for glass. She's colder than ice. She's close but yet so far. She's out of my world. She's become my newest star. I looked up at the stars above to finally see exactly what it was she never saw in me. I just had to know. She's looking back. She got stars in her eyes. She belongs to the world now. She's no longer mine. She's looking back. She got stars in her eyes. She belongs to the world now. She's no longer mine, no longer mine. Just like the ball, she was born to run. Just like the Stones, can't always get what you want. Just like the Beatles, it won't be long. Just like the eagle, she's already gone. Now our future looks bright. I know we'll go far. Since I saw the first light of that solitary star. Looking back now, it's all clear to me that whatever she finds will rewrite our history. I looked up at the stars above to finally see exactly what it was she never saw in me. I just had to know. She's looking back.
I'm looking back.
She got stars in her
I got
eyes.
stars in my eyes.
She belongs to the world
I
now.
belong to the world
She's
now.
no longer mine.
He's no longer mine.
She's looking back.
I'm looking back.
She got stars in her
I got
eyes.
stars in my eyes.
She belongs to the world now. She's no longer mine, no longer mine.
You know, he didn't do anything. He just kind of everybody wants to
Does everyone get a pair of the glasses? If not, I mean, like that. Too many. For the watch party. If not, please let me know. It's up to you. Thank you for being here. Excited. That's the solar eclipse, the partial solar eclipse today.
Yeah.
Out of Stafford. Did you all? Dr. Wilson, reminder, we will have pizza lunch after the solar eclipse, so hang tight. We'll come back in here, come back to this room. And Dr. Tapa is going to enlighten us on the eclipse. So whenever you're ready, Dr. Tapa, the floor is yours.
All right. First of all, I want to welcome you all to this event. This does not really happen so often. All right. So we are happy to experience some eclipse. Well, the main part is not yet in Houston, but we see just a part of it. If you are outside already, you have the little glass we are passing out. It's already started happening already, so you can actually see where the moon is crossing between the earth and sun. So we are going to learn a little bit about the science of eclipse. And we have here, I am the chair of natural sciences. My name is Cyril Anoka, and I have here with us Dr. Tapa, who is the associate chair of natural sciences. I will have most of our faculty here, both the geology, astronomy, and physics faculty. I will have you guys to speak to any one of us when we are done. We have a lot of items, snacks, pizza, while we watch. And this event will occur close to 12 o'clock in the afternoon. So we're going to have a little bit of some kind of presentation for you to understand what is going on. And you should be able to explain to your friends and folks, and hopefully, for you guys can see, so some of you will be our students when you be able to take either geology course or astronomy to understand a little better what is going on. All right, Dr. Tapa, over to you.
Thank you, Dr. Rosa. Welcome, everyone. So, this event is hosted by the Division of Sciences and the Geology Department. This is a very great event here. For us, welcome. Let's start the show without no view. I'm actually displayed exactly right now what you see out there. And with the every class,
Good advice.
it's beautiful, but it has to rise. So those who can directly need to have this class, which we have enough for everyone. Okay, when you go out there. So that's what you see. The paintings has already started. You go out there, that's what you see. That's the moon. The moon is coming in front of the sun. Okay, coming from the sun, and eventually, if it could, it will try to block it, but unfortunately, it can't block it today. Why? Let's see the science behind that. This is our model. Okay, that's the Earth, Moon, the Sun. Okay, as you can see, the distance of the Moon from us is very short. Okay, compared to how far away it is from the sun. That's very important. Okay, but here is fixed. This distance, the distance between the Earth and the Moon is fixed. In reality, it is not. Actually, sometimes the Moon gets closer to us. Sometimes it gets out further out there. It's about, if I can estimate, the difference between the closest and the furthest point is about 17,000 kilometers. 17,000 kilometers is really big for us, but for the celestial objects, that's basically nothing. So that's why we consider, okay, the moon to orbit us in circular orbit. It's not circle, it is ellipse. So that's why sometimes it's far out there, sometimes get closer to us. Now, not just for the moon and the earth. That holds also for the sun and the earth. So let's see what will happen as the earth goes around the sun. Look at what the moon is doing. See that? Right here. What do you see? They're all aligned, right? The moon is between. No, the earth is between the moon and. Then now you have what we call lunar eclipse. See that? That is night. This is day. The phase of when we are facing the sun, that's during the daytime. We are not facing when you are here. That's night. So during the night time, you can go out there and enjoy lunar eclipse when that alignment happens. Okay? Let's go, keep on rotating. As you go around, that happens. Now what happens? Solar eclipse happens because we are on the other side of the moon, and the moon is between us and the sun. But the moon is so small. You see that? So small. The eclipse is basically its shadow on us. The shadow it has on the earth is very small. It's not that wide, so that covers the entire globe. It covers a very narrow part. As a result, not everybody sees this eclipse. Only people who are on the path of the eclipse could see the total or the total eclipse. So what we see here is partial, because we are not on the path of the eclipse. We are a little off to the north. The eclipse path is just south of us to the west. So if you are at Corpus Christi or if you are at San Antonio today, you are going to see, as they say, what is it called? The annular eclipse. Yes, it's called annular eclipse. Okay. And the moon at this time is a little further out. It's a little further out than usual. So it's not going to cover the entire sun. So you're going to see kind of ring of fire when you look at the sun. If you are, as I said, down to Corpus Christi or to the west, if you go to San Antonio, that's what you have seen. But we'll see a little of that around 11:58 when we go out there. So that's what we're going to see. Let's see what will happen at the peak. So I'm going forward in time here. This software gives us what happens. Let's see, 8. You can see now, summary. At the peak, that's what you see. Crescent sun, right? So how do we watch it? As we say, you will use your glass, or actually you can see this by the shadow of the leaves of the trees or anything that on the ground. You can see that's what we see. Why do we see the entirely right now? Because you can see the whole sun. When it is covered, the image you see is basically the image of the sun on the ground. So you can take that picture also from the leaves to understand the eclipse. Okay, before closing, let me change these to Amazon. Okay, let me take it. I leave that there, but San Antonio, as I say, what you see or corporate Christi, you see is very thin line circling the moon. That's what you will have seen if we are on the path of the eclipse. How often do we see this? On average, I think the rate is about 3 per year on average. Sometimes there are also times where you cannot see them. This time, next year, April 8, if I'm not mistaken, we are going to see another eclipse going to come our way. Okay? That eclipse, unfortunately, we are not on the path again. Okay? So you have to go a little north to Waco, or a little further to the south to see on the path of the totality of that eclipse. Okay. So that is more exciting because, folks, at 1:30 on April 8, 2024, all of a sudden you can see the stars. 1:30 in the afternoon. Not just that, we cannot see what is happening around the sun. Okay, the sun's environment during the day. To see that, what you have to do, you have to cover the sun. The moon will cover it for us so that we can study the sun. So that's why that is exciting. Everywhere, scientists flow to see that on that day. Okay, so that's another thing, another news I wanted to share with you. I want to miss it. How many of these have you seen in your lifetime? Exactly. So that is why how rare it is, and I'm really excited to have you here at the World Day party with you. And again, welcome. And now a few minutes with the geology department. There, as I said, they hosted also with us. So they're going to say a few things about their program. I'm handing it over to the geology program coordinator, Professor Yu.
I'm really glad to see all of you here. It makes me very joyful that I'm not presenting to like 10 people that came to our event. So this is glorious. One of the other fields of science that kind of filters in our Texas curriculum is earth science, the geosciences, and actually eclipses are within our solar system. Planetary science and stuff in our solar system, that's part of geosciences, planetary sciences, studying the processes of our own planet and the materials that our planet is made of are part of our solar system. The history of Earth shares a bit of history with the moon and the other planets and the bodies that are orbiting Sun. I would really like to invite all of you, as you're planning your future semesters and higher education, to consider the earth sciences in your schedule and enrolling in our courses. And here at HCC, we have a number of classes that fill kind of the core curriculum as you're either deciding on a general science degree, like the general associated science degree. We have earth science, we have environmental science, we have oceanography, and meteorology. Those are all non-lab classes. They're the sort of 3-hour classes. If you are just kind of needing to check off the 6 hours of core curriculum or otherwise kind of fill those hours. We explore the oceans, we explore the atmosphere, we explore the physical earth and the materials that they're made of, and also things that are kind of exciting, like geological hazards, earth hazards. Another way to approach the geosciences, if they really already kind of spark your interest and you want to know more, then we offer a geology associate of science degree, and the coursework that's in that degree plan would prepare you for transferring to a 4-year degree, to a bachelor of geology or geophysics or other kind of earth sciences. So we have a lot of pathways to go from the coursework at HCC to universities across Texas. Our courses transfer and help you on in those. And so the two that are listed here, physical geology and historical geology, are our lecture lab classes. So those are where we have hands-on, looking at rocks, looking at minerals, exploring maps and kind of really applying those geological concepts into actual kind of problems and working through issues. So one of the things to also think about, not just what are you going to do at HCC, but where are you going to go after, because we really see that this is where you start. We give you all the great basics of your intro chemistry and math classes and physics classes, but also then where might you transfer? So one of the opportunities, besides the large number of universities across Texas, is we actually have Chuck Coy here, who has sponsored a scholarship specifically for community college students interested in transferring into a Bachelor of Geology program at Sam Houston State University. So I'd love him to share with you a little bit about that and about kind of career paths that they follow after earning your degree for just a couple minutes.
Perfect. Thank you very much, Professor. Yeah, I am Chuck Coy. Really a pleasure to meet all of you students that are working hard to improve your lives and finish right here at HCC in a fabulous program. I am a professional geologist. I've had fabulous careers. Does anybody here like travel, going overseas, different places? I've seen most of the world as my career. Many jobs in geology allow you to do that. My career is in energy, but there are many other things that you can do. I have good friends that are in astrogeology, which we're looking at today. I have friends that are in carbon capture, concerned about the environment. We all are. I have a friend here in Houston, another one in Adelaide, Australia, working on carbon capture, utilization, and storage. I have friends that are involved in environmental geology, including a student who just graduated from my alma mater, the University of Texas, and she just got a job with the Texas Water Quality Commission. Man, is she ever happy about that. So there are all these jobs available to you. All right, complete your studies here with 2 years at HCC in science. It doesn't have to be geology, but in science. You enter then in the geology program at San Francisco State University, all across the country.
Full scholarship.
Full scholarship, the cost of living, meals, tuition, all that is covered for 2 years in the Bachelor of Science. Have a fabulous career or go on. I have a very close scholarship student now. He finished his junior year last year. He's going to go in for his senior year. He's doing fabulous. He's looking at going on to graduate. But he had a really good internship last summer in energy, and he can continue with that if he wants. All right, I have recently met with students at Louisiana State University, University of Texas, and at University of Houston downtown. Those students either all have jobs, really well-paying jobs, or they're going on to graduate. I want to expose you to this opportunity. It's a fabulous career, and it's not for everybody. I think the best that I can speak, I think Dr. Papa mentioned that. Find something you really enjoy, and that's the most important thing. Man, have I had fun with this. Thank you very much. Thank you. All the information. Just contact us, okay? Let's go see this clip.
Thank you.
How are you all doing today? All right. Y'all look like very happy people to spend your quality time on a Saturday at school. I love your half-hearted pauses. Thank you for the pity laugh. And yes, there will be jokes during my presentation, so if I don't get ha-has, I cry in the corner later. All right, another pretty laugh. Appreciate that as well. And yes, we're going to be a lot. Thank you as well for the pity laugh. All right, so yes, I am Professor Duval, and I am the program coordinator and faculty for speech communications. We actually teach this kind of stuff, public speaking, intro to communication, business communication. And for those of you who are all about relationships and heartbreaks and love, we also teach interpersonal communication. No one's into love anymore. Really? That's a hard no. All right, very good. Now that we are a loveless society, this makes me very happy. Any questions before we officially get started? No hands raised. Give me a question. It's been pretty good. I got my McDonald's coffee in, and now I'm popped up on caffeine. It is black with 3 grapes. That's it. No sugar. Just good old fashioned coffee. Okay. Yes. Say again?
What kind of roast was the coffee?
No idea. Whatever has caffeine, I drink. That's how I usually do it. Any other questions? All right, if nothing else, I guess we can get started. How's that sound? That sounds good. All right, thank you for that.
I'm excited.
You're excited. All right, very good. I like that. So let's get started here. Probably like this. Oh. All right, cool. So this has been tailored for all of you as you do your pitches tomorrow. You're doing your pitch. All right, this is tailored for all of you as you do your pitches because I know you don't have a lot of time, and so that's why for these kinds of situations, it does matter to tailor and craft your speeches for these types of situations. And one of the first things you have to always take into consideration is your word choice, your language. This matters a lot, because you don't have a lot of time. You have to figure out the right words with the right people for the right outcome. And one of the things I try to do for my classes as much as I can is I try to have a conversation with all of you. There's a very big difference, and you know the psychological effect that comes with when you're listening to a lecture where it feels like a conversation versus someone just talking to you or at you. And this is one of the things I want you to strive to achieve is to have the conversation with the people who want to invest in your idea or go with your idea. And one of the ways to do this is with rich descriptors, your word choices in order to bring about immediacy. Does anyone know what this is? No, because that's why you're here. The immediacy that you have with the audience members that you're talking to, it's sort of like that barrier going away. There's a barrier between you and the other person. When you're having a conversation one-on-one with someone, do you feel connected?
Yes.
That is what I want you to do as you're giving your speech. Connect with your audience members by using rich descriptors to bring about immediacy between you and the listener. Word economy. Brevity is a big deal. How much time do y'all have for tomorrow? 3 minutes. 3 minutes. Not a lot of time. And that's why brevity will be your best friend. And this is why being able to find the right words within that amount of time to say everything you need to say matters a lot. And you're all very smart people. I know you can do this all within 3 minutes time with whatever idea that you have. One of the best ways to do this is with a metaphor. And yes, metaphors are your best friend because there's going to be ideas and concepts that you'll know very well that maybe they may not. And so you have to help them bring about the understanding by using metaphors. We'll have to talk quite a bit more about that in just a sec. The next thing now, audience analysis. Now for this case, it's not so much the who, because a lot of the times in public speaking, you want to know who their audience is. But in this case here, it's about the what and the why for your idea. And that matters a lot. Because in regular public speaking, you try to figure out people's attitudes, values, and beliefs. But in this case here, the more of showcasing and having people see the vision that you have and to bring that into reality. And one of the things I do not want you to do, before I get to that, look at the competition rules. And this is where what the why is going to be the utmost in this case. But one thing I don't want you to do, jargon. Does anyone know what this is? I heard it yet. What is it? Yeah, it's a question. Yeah, exactly. Very good. See, smart people. You may know it. It's efficient. It's great within the organization or within the work group that you're in. But they won't get it. And that's the one thing that we want to try to avoid is to use language where they don't know what it means. You don't want to do that. You want to use a language where anyone can understand. Jargon is efficient. It does a great job within the work group. But for the general public, This is something we want to avoid because we want people to have a full understanding of whatever your message may be. Another thing is to use language explicit to competition. As you're reading the rules, make sure that the language that you use adheres to everything you need to say. And it gives them the cue that you know what you're talking about, and more importantly, that you read the rules and you're ready to have them invest in you. And this actually gets to the aspect of speaking of the stakeholder. Because your vision, your idea, it's a big deal to you, right? At least it should. Make it a big deal to them as well. Make it matter to them. And by doing this, you'll be able to capture the audience's attention. Hopefully, they'll want to go with your idea, whatever it may be, when you're choosing the right words for it. Developing PowerPoints. There's one thing I should say. Please, don't use a PowerPoint as a crutch. Fortunately, there's been plenty of people who have done that. It's there to aid you, not to replace you. Keep that in mind. And as you're developing your PowerPoint, less is more. Because who here would honestly want to read a PowerPoint that's a paragraph long? No. Will it put you to sleep? Yes. Yes, it will. And this is why PowerPoints matter a lot. They're only there to aid you. Use the right colors, attractive colors to the eyes. By this, I mean don't have like a yellow background with red font coloring. It's a great way to make people very angry at you for the next 3 minutes. Try not to use so much effects. It looks cool, great, but they're not there for the effects. They're there for you and your message. And the one thing I would always say is, if you want to use media, be judicious about it. I always like to have students, when they're giving a 5-minute speech, to use a video for only 30 seconds. Because we're not here to watch a movie. We're here to listen to you, the person, your idea, wherever it may be. So you have to be judicious about what kinds of media you want to use, what effects you want to use. And if you are not at all a graphic designer, find someone who is to give you some beautiful colors to work with. Usually neutrals work great, but if you can make it attractive, even better. Minimal text, yes, we do not want to read full paragraphs because the last thing I want to do, and you want to do, is put people to sleep. I do that enough in my daily life. You don't need, I don't want to do that to you. I don't need to do that to them as well. And this is the one thing that always gets me, is when I see students who have a PowerPoint, but what do you think happens sometimes?
They read off of it.
They read off. Don't do that. You don't want to do that. Because again, if I'm just doing this to all of you for the next 20 minutes, how would you like that? Thank you. Thank you for that. But still, I'm not looking at it anymore. I'm just reading off my PowerPoint. You don't want to do that. This breaks the immediacy that you have with the audience members. And we're going for the opposite thing. We want the immediacy. Don't just look all at the PowerPoint all the time, because then it becomes a crutch. That means you need to practice with your PowerPoint. And practice with one of these as well, because sometimes I've seen students fumble, and time is a big deal for all of you. We do not want you to fumble with a PowerPoint that's supposed to help get your message out, and hopefully not to hinder it. Vocal variety. Any singers in here? Like just 2 ish singers. Singer over there.
I mean, my cat thinks I'm a good singer.
Where your cat is evil, number 1. And number 2, yes, we got a singer over here. So, your voice. Everyone has a voice. I have one, you have one. One thing I want you to do with it, project. Yes, we can be soft-spoken people. Yes, our volumes need to be a little higher. There's a very big difference between projecting your voice, for your voice to be heard by everybody, and yelling. There's a very big difference. No one likes to be yelled at, right? Well, maybe you do. But everyone else, everyone else does not like to be yelled at. But project your voice. You can do this. And sometimes, yes, you gotta take a breath in. And that actually is one of the things that singers know how to do is to take breath and know how to project your voice in. Because you have to be heard by all. Because if I'm always doing this, no one can really hear me all that well. So take that breath, project your voice. Don't speak too fast, don't speak too slow, have the right pacing. To be honest, some people have fast pace. That's just how they naturally speak. Sometimes you'll find yourself doing better when you slow down your speech just a little bit. And at that point, you'll find yourself having more articulation, more control, and you'll find yourself having a little bit more confidence when you slow down just a little bit. Not a lot, but just a hint. You'd be very surprising the effect that'll have and how you deliver your speech. Strike the right tone. Now, this is all about ethics. So, what if I should give the speech like this? So today I'm talking about.
Hey, what did you say?
What was my tone like? What am I giving off to the audience members?
Yes, a fast word.
I have a surprise, no surprise. I'm shy. I'm very shy. My tone, it was not matching the expectations that the audience was looking for. If you want people to be excited about your idea, about your vision, you have to be excited too. If you want people to really engage with you, you've got to engage with them. And your voice does a great job of this. And some of us can sometimes, to be honest, have a monotone voice. That happens. But realize you actually have varying tones that you can use. Because some people can go really low with their voices. And some people can have a nice persona with their voices. I'm not saying for you. I'm not saying for you to take that on, but use the varying tones that you have and use them correctly and with purpose in order to create that immediacy with your audience members. As in, sorry, we all know what that's like. And when you're listening to someone for 40 minutes and they're all monotone, what does that do to you? Yeah, that's it. Exactly. Puts you to sleep, you're bored, and you're no longer having anyone paying attention to you. Don't do that. Use your tone, your varying tones that you all have. And please, 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 use it with purpose. Just don't just throw it out there for the sake of throwing it out there. Pauses. Now, this is a good one. And I'll like to use an example of a joke. Who wants to hear a joke? All right, this is the nerds out there. What do you call a sheep with no legs in a calculator? And my pause was way too long. And the answer is cloud computing. Yeah, sheep, well, no legs, calculator. All right, thank you for the pity laughs, I appreciate it. But my punchline for my joke, it went way too long. And it sort of had a jarring effect with the audience members. Now let me try it with a different joke. What do you call a sheep with no legs? A cloud. I don't need your pity.
I think if you give it a little more of a pause, and if it was actually a good joke, a little bit
If it were a good joke, I know. But that's why I'm really using it as an example. But yes, timing your pauses matters quite a lot. And using those two jokes as an example, you can see how the timing of the punchline, where it came in, It was either good or really bad. Use pauses in your speeches. Use them effectively. And this actually gets to another point where you can use it instead of saying fluencies like your ums and your uhs and your likes or your yas, because that seems to be the new one now. A lot of yas in speeches I'm hearing lately. Instead of saying those, pause like that. And so you can use it instead of the other this one. So you can just use the pause. Stop talking for that brief moment. Collect your thoughts and go from there. Articulation. Say the words clearly with a crisp manner. That way everyone can listen and hear the words that you are saying. And if it matters, well, and to say it correctly. By this, I mean, there is a very big difference between specific and specific. Big difference. So we cannot be lazy with our words. We have to be able to say the whole words with a clip, and here's me doing it, in a crisp, clear manner. Now dialects, this is something I actually like a lot. Who here has a dialect? Everyone does. Everybody does. Yes. Everyone has an accent. Everyone has a dialect. And I think they're all fantastic. Sometimes, though, as some of you have realized who may have English as a second language, or if you speak a different language and speak in that language, that you have to really try a little bit harder to say the words correctly. And sometimes you'll have to do that, because what you're really trying to do is be understood by everybody. And so sometimes, yes, gotta clean up just a little bit the words that you're saying for those who have a very heavy accent or a very heavy dialect. Keep it simple. Can't stress this enough. Avoid jargon. So, pronouns. Let's talk about this. I'm going to come up to you. I'll probably just say that you so I'll come up to you. How does it feel when I say you have a problem?
Sure.
Well, versus we have a problem. Well, there's a problem here, but what's the difference? Yes. I'll tell you raising your hand. Let's see. So, when I used you, did it feel like I was attacking you a little?
Yeah.
When I used we.
Feels like more of an attack though. We have a problem here.
Yeah, we're on a team. Yeah.
It feels like more of a threat. Like we're gonna have a problem.
No, as in we have something to solve versus you have something to solve. You can see the difference in how we use the words of you and we. And of course, we goes a lot farther than just using the words like you. So consider we, because at some point, if you get that someone to invest in your vision, it will be a we. It cannot just be a you or simile, metaphors, and analogies. I think we all know what a simile is, right? Like or as. So I'll use me for an example. Professor Dufault is like a dinosaur. No laughs. I'll take that. So, simple enough. Metaphor. I'll use me as an example again. Dinosaurs could walk, it'd be Professor Dufault. Thank you. I appreciate the pity once again. And of course, analogies. Now, this will actually be your best friend for sure, because, again, there's going to be some concepts that you know, but they won't know it. There'll be some ideas that you have, but they don't fully understand. So using similes, metaphors, analogies helps bring about an understanding to the audience members, because you all have some great ideas. You all know a lot of things, but sometimes you have to use comparisons in order to have people have an understanding of what your message is about. Repetition. No, use strategically. It could go well, very well. Anaphora. Today, y'all had pizza. Today, I gotta know. Today, we were all here enjoying Professor Duvall's effective communication workshop. Now, if you're using it before the sentence, it starts to create a good rhythm with the audience members. And you can also use it at the end, which is also known as the epiphora. So, y'all had pizza today. You're all here with me today. And we are all a bunch of weird, smart people today. I wouldn't say that. No. But you can start to see the kind of effect that it takes on with the audience members, depending on if you're going to use a anaphora or a. Another thing you should consider using is, as you're questioning back, when you're using parallelism and antithesis. And I'll give you a great example of this. It was the best of times, it was the worst of times. You want to know who that was by? Cities. But just for those two sentences alone, what did it create for the audience members?
A sense of mystery, like you want to know what they're actually talking about.
Exactly. Create this into drama for the audiences. And really got them more engaged in the things that I'm talking about. This is what it means to be able to craft your speech with the right words and with the right structure. One thing I do want you to avoid, though, cliches. Now, this is the one I hate a lot. That's the way the cookie crumbles. But who can give me a few more cliches out there?
Love, laugh.
Oh, yes, another terrible one. Live, love, laugh. What's one more cliche? Teamwork makes the dream work. What a cliche. Excellent job. You're smart people. You can come up with something much, much better than just the cliches. Excellent job. As Ravi said, practice. Practice. One of the more effective ways to do this, record yourself. And I'll be honest, there are many artists out there. By artists, I mean singers who do concerts. They record themselves to see where they made the mistakes and to clean it up. Best example of this is my favorite artist, Prince. Every single concert he played at, he recorded. So he can see where he made mistakes in order not to have them happen again. I would highly say for you all to do this as well. It's weird, I'm not gonna lie. Watching yourself on TV is weird. Listening to yourself on TV is weird. But once you get past that weirdness, and you really start to see some of the mistakes you make, because we all do make mistakes, you can start to see where you need to clean things up. So practice it, and record yourself so you can see how well you did. Non-verbal communication. Now this is very important as well. So, when it comes to using your nonverbal cues, it does help people to want to trust you a bit more. Now imagine, and I'll do this as an example, I just stood here for 20 minutes, stared straight away, and just lectured like this. I got a huge no. Why a huge no? It's awkward. Yes, do you trust me? Not really? Definitely not. You're human. Be human. And have human movements. And that is okay to do. Yes, it can be a little jittery being up here. Yes, it can also feel like that all the eyes are on you, but that's okay. Because you're all still human and you should still have human movement as well. Because as you move around, just like you do in conversation with your best friend, with your boyfriend or girlfriend, or both, people just have that. You can also have those movements as well. So translate that into your pitch. And to also make sure that the words matches your movements. Because if I'm always doing something like this, how's everyone doing today? Hopefully good. Very weird, right? Now imagine if that were synced up in the words I was trying to say with it. Yes, I'm not a robot, I promise. I promise I am not a robot. I don't know. We'll have to see later. So we're going to talk about these in just a bit, because this is all strategies to boost your confidence. Eye contact. Look at the people. Don't look at the PowerPoint, look at the people. Don't just look at one person, because if I'm always doing this, staring at you only all the time, already he's scared. Don't be scared. Look at everybody. Look at everybody. Have eye contact with everybody. Because if I'm giving a lecture looking at my feet, what's everyone doing today?
You look disappointed.
It's an everyday feel for me. Step today. No ha-has. No, you said I look disappointed.
Oh.
Yeah. So when you look at your feet, it gives off a very different message to the audience. Now, if I'm always doing this, how's everyone doing today? Very good, very good. Yeah. Look at the people, look at everybody, because you want to have that connection with the audience members. Body language. It matters a lot to have the right posture, because this goes into there not just boosting confidence, but also to help you project your voice. Because when you have an upright posture, you're able to breathe quite a bit better in order to project your voice. It also helps you with your confidence and how you feel up here. Because if I'm always like this, I have a lot of confidence, but that's why I like to keep it back straight in, so I can breathe and project my voice. Gestures. Someone give me some jazz hands. All right, very good. Don't do that. Not up here. But definitely use these things that we have. Yes, yes, the fingers. But you got to consider that sometimes, depending on our hand movements, and symbolize things. Because if I'm always telling you or using my hand gestures doing this, it has a different effect when I'm doing this, or this, or this, or this, or the bottom. And so that's why it matters quite a lot to use your hands, but to use them effectively and in the right way, and use them naturally. Again, don't just throw it out there just for the sake of throwing it out there. Physical movement. This is where it actually does help to be able to move around just a bit. If you have a stage, go ahead and use it. If you need to look at everybody. If you want to stay behind the podium, move around it a little bit, you can do that as well. But remember, you are all humans. You're not robots. Have the human movements, the natural movements you all do on a daily basis when you're having a one-on-one conversation with your friends and family. Personal appearance. So, the question for all of you, would you truly respect me if I came up here with jean shorts, a tank top, and sandals?
I wouldn't.
Yeah. So, dress for the part. Dress for the part. Because the audience members have an expectation, and at the same time, as you dress up, The confidence does go up. Who here feels fantastic when they dress to the nines? There we go. Yes, yes, yes. That's why it matters a lot to dress up. Because yes, it does have an effect on you as a person and how you deliver speech. Tone of voice, I think we already covered that part quite a bit. Just be sure to use it in the right way. All right. I'll be honest. This was not me for a long time. By that I mean being an effective communicator. This took time to develop because I'm usually that guy in the corner, shy, and not willing to talk to people because just being afraid to talk to people. Once upon a time. Because to really communicate with people, it does take development of skills. And especially to do something like this. Oh yes. Especially speaking from so many strangers, I developed that skill as well. Same thing I have to do before I pitch, which is to practice. And yes, everyone has different style of communication. This is just my style. Have your own. I'm not saying for you to be that one speaker that you've seen, to be that person. Exactly. You're your own person. You have your own style. You have your own way. Use it to your advantage. Be the person that you are and showcase it up. Because I don't want you to be somebody else. Because then the confidence won't be there as you would expect it to be. And more importantly, I want the naturalness to come out as talk to people. And so that's why all these things comes back to speaking with confidence, with practice. Be prepared. Please, please, please be prepared. What is your message? Be aware of how you are in front of people. How do you look in front of people? Ask questions because, hey, you have plenty of people here wanting to help you, to see you do well. Practice your communication skills. I know that sounds like a PBS special, but yes, it does matter to believe in yourself. It matters quite a lot. And one of the big things I would say is to envision yourself doing it, not failing. Because even though it's not a guarantee, it goes a long way when you see yourself doing something and not failing. It helps a lot, I promise. All right. During presentations, pathos. If you want people excited about your idea, you be excited first. Because we want people and the audience members to engage with you. Just remember, it starts with you. What is your audience needs? This actually goes back to the rules of the competition that you all, I'm sure you all read already. Concentrate on that core message by keeping it simple. Yes, it does matter to smile. It really does. Because, again, it goes back to showcasing the emotions that you have and being excited about the project or vision or idea that you have in order for people to be excited about it as well. And yes, eyes and eyes in order to have that eye contact with the audience. Start strong, and strong. And I think there's no explanation for this one, right? Use your voice effectively. And don't forget this weird thing we call our body. Use it and use it well. There we go. And yes, no clap here. I went a little bit too far. Relax. Relax. I know it's a competition, but I want you to enjoy yourself still. Because one of the big things that you're doing is you're getting your idea out there. Showcasing your vision to everybody. Not everyone has a chance to do that. So be excited in being able to do this and relax. You got this. Please, please, please remember to breathe. I know you want to clap so bad. Just remember to breathe. Take that breath and enjoy the time. Now you can clap. Thank you. there's going to be a second half to this, but it's just me for today. So any questions, comments, concerns, or hate mail? Yes?
That was a great presentation.
Thank you, I appreciate that. Anybody else? Questions, comments, concerns? Yes, thumbs up. Miss the first slide? How do you miss the first slide? All right. I don't know what y'all have going on. I'll be here for a bit longer if you have any other questions that should come up. I hope this has helped, and I hope you all do very well tomorrow. Thank you for your time.
Awesome. All right. So, to really finalize, there are some faculty who have come by and left their names with me. If you're still looking for a faculty mentor, if you already have one, we have some folks that we can recommend. You'll email them or go see them in the other side of the building where they're available to listen to your pitch and give you feedback. Okay? But I'll also share the link where you will submit your projects before 11 a.m. tomorrow. So I'm keeping that a mystery, but I will be posting that on our Inventathon website. But I'll put a QR code here for you, since you're here in the room. So that's the place you're going to upload your presentation. The link will take you to a website where your project with your name will be made available as a portfolio project, and it'll live on there, for many, many, many more years. You can update it as well. But if you wanted to show somewhere on a college application or for someone that you got that skill and you have worked on that project, that will live online as your digital portfolio. Make sense? So use that, and stuff you do in school that you're really proud of, you can have it as your portfolio for future projects, showing off that skills in whatever you're trying to get a job for. Yes. You're gonna have, so the requirement as of right now for it is a white paper. Could be, who remembers the max number of pages for a minute paper? It's
5 to 8 pages.
5 to 8 pages. So minimum 5?
Yes.
Maximum 8?
Yeah.
Does that include the cover page?
So, no, so the rubric says,
It's a technical paper. Okay? You can Google for a format of technical paper. You are free to use ChatGPT and everything else as long as you read it and clean it up. I'm not against any type of AI tools that help you be productive. That's what this hackathon is about. We're not going to say or shy away from it, but it has to be your idea. And the ChatGPT is just making it nicer for you. That's okay. But it has to be your idea. And you're typing it up, and you're making it more convincing. That's okay with me. But you will have to present it. Computer's not going to read it out. So whatever is the output that's on your technical paper, that's on your PowerPoint, you have to own it. You have to know what you're talking about. You have to practice. Because you are the expert of that idea. Okay? And then when you post it on the link that I give you, the link is going to be for DevPost. DevPost is an online website for all hackathons. That's where you're posting. It will live on DevPost as your product. Your name will be tied to it, so no one can later, claim that they took it. It's your idea, your project, and it's in the public domain under your name and your team's name. Important that every team member signs up. Important that you add everyone on the team. If your team wins and your team member is not listed on there, and when I'm giving out money for the winning prize, your team member is not on there, I'm not going to go change. Whatever submitted at 11, that is the team. Whatever you submitted as the project, that is the idea. If you win, that's the group I'm writing the check to. You cannot add people or remove people, all that, none of that stuff. 11 o'clock's the snapshot of whatever it is. That's what we're running with, okay? Any questions? Take a break, come back in about 5 minutes. Give me some opportunity to get some of my stuff ready. Round of applause for Mr. James for coming out and telling us about. And go. Bio break, bathrooms on the sides, and we'll